We said there were three broad types of errors that computer programmers encounter, and we've talked about two of them. The first was the syntax error. In that case, the interpreter can't figure out what you've written. We've talked about runtime errors, where some state of the program or unwanted user input causes the program to stop running. In each of these cases, we get some feedback. In the case of the syntax error, we can't even run the program, and the interpreter will let us know which line it's struggling with. In the case of the runtime error, the program stops unexpectedly, and the interpreter gives us a message about what line the program stopped on, and also sometimes some context about what other things were happening at the time. The most insidious error is the logic error. In this case, the program behaves unexpectedly because of some bug in the code. The reason the logic error is insidious is that Python doesn't realize necessarily that something's wrong. The program may not stop running because of a logic error, or it may stop running many lines later. Logic errors are generally the hardest to track down. Let's give an example. Suppose I have a function called convert. And this function takes one argument, tempf, temperature in Fahrenheit, and it will convert it to Celsius. It's a one-liner and just does some simple math. And then, of course, we have our main function, which will consist of a while loop. We'll start by initializing a Boolean variable, boiling, and set it to false. Our loop condition will be not boiling, meaning we'll loop as long as our water is not boiling. And we'll ask the user what the temperature of the water is. Remember that the input function returns a string, so we take the user input, convert it to a float, and store the result in response. Now we want to know if the water is boiling, so we will convert the temperature in Fahrenheit to Celsius using our function. And we know that the boiling point is 100 degrees Celsius, so we say if temp C is greater than 100, we will set the Boolean variable boiling to true. Once the loop exits, we print a friendly message, and that's the end of our function. So the point of this function is to continuously ask the user for input, what is the temperature of the water, until the water reaches 100 degrees Celsius. At that point, the loop will exit, and we will print this friendly message. Let's try it. All right, so our water is only 70 degrees. Ask us again. 90 degrees. 150 degrees. We know that the boiling point of water in Fahrenheit is 212 degrees. So if we go to 213, it should be boiling. But for some reason, our program is not stopping. Let's go to 250. Oh, okay. Something's wrong. We expected the program to stop when the temperature exceeded 212 degrees, but for some reason, it's looking for a higher number. Notice that the program never gave us an error. Python was very happy executing our code. Remember that the computer doesn't really understand what you're trying to do. It's just following your directions. So what we're dealing with here is a logic error. It's not a syntax error or a runtime error because the program ran just fine. We just didn't get the result we expected. So we have to look back in our code to figure out where the logic error is. Could it be in this conversion from a string to a float? Could it be that we coded the wrong Celsius temperature here? Could it be something with our while condition? Or maybe there's a problem with the conversion function. Our natural response when we see an error is to look around the place where the error happened. So we might be focusing on this statement here. Or we might step through the statements in the while loop to try to figure out what's wrong. But in fact, there's nothing wrong with our while loop. The error is coming from outside our main function. There's a problem in the conversion function because we didn't follow order of operations correctly. If I add parentheses here, our errors should be fixed. You might have spotted that a long time ago. Let's run the program again. We'll try 200 degrees, 212 degrees, and then 213. And now our program responds correctly. This was a fairly simple example because our code is very short. But if you imagine a program that has many, many functions that maybe refer to each other in a tangled web, you can imagine that these type of errors can be very hard to track down.